Right now, a faint narrowband transmission, measured at just 0.08 watts per square meter, continues to pulse from the interstellar object known as 3I/Atlas as it drifts past the orbit of Neptune. The frequency, fixed at 1420.405 MHz, sits impossibly clean within the hydrogen line where cosmic noise should drown everything. And for the first time, an autonomous AI has decoded its structure, revealing patterns that physics cannot easily explain. The data says accidental, yet the symmetry says intention. At 54 kilometers per second, an object the color of extinguished embers slipped across the heliopause and entered the solar system without fanfare. No flare of reflected sunlight announced its arrival. No trail of evaporated ice betrayed its motion. Instead, it moved like a shadow with mass, an elongated silhouette barely distinguishable from the blackness behind it. Telescopes caught it only because of its disruption of background starlight, dimming patterns with an exactness too geometric for random debris. This was the moment the world first recorded the presence of 3I/Atlas, the third interstellar traveler ever observed, and the first to behave as if darkness were its preferred camouflage. Its albedo was astonishingly low, far below that of carbonaceous chondrites or metallic asteroids. The object absorbed nearly everything the sun cast upon it, giving off only the faintest whisper of thermal radiation. Spectroscopic analysis revealed no familiar minerals, no organic volatiles, no metallic lines. Instead, its spectrum flattened into a uniform absorption curve, as though the surface possessed a material engineered to erase its own presence. Against the cold vacuum, 3I/Atlas appeared less like a natural body and more like a void sculpted into form. Yet the darkness was only its first anomaly. As radio observatories synchronized their arrays, a quiet but unmistakable emission emerged from the coordinates of the passing object. Centered precisely at 1420.405 MHz, the hydrogen line frequency, long considered a universal beacon in the search for extraterrestrial intelligence, the signal persisted with unyielding stability. At first, researchers blamed foreground interference or instrumental artifacts. Hydrogen line noise is common across the cosmos, a natural byproduct of atomic transitions. But the emission from 3I/Atlas refused to behave like noise. It pulsed with a modulation cycle of 53.77 seconds, stable to 8 decimal places, stability no natural plasma turbulence had ever produced. As the weeks progressed and the object drew nearer to the sun, the signal intensified. Not in random bursts, but in a logarithmic climb that traced an elegant mathematical curve. Observatories from Hawaii to Chile recorded identical results. Every model of outgassing, thermal expansion, and rotational harmonics failed. The emission did not scatter. It did not drift. It did not respond to gravitational tides. Instead, its architecture remained precise, as though tuned to match a function only it understood. This precision raised a question no astrophysicist wanted to articulate. Was the signal a byproduct of the object, or a purpose? The closer 3I/Atlas moved toward perihelion, the more the pattern resembled the output of an engineered timing system, something regulating, encoding, perhaps even transmitting. A natural object should not behave like a metronome. A natural object should not generate a frequency so deliberately centered where any technologically literate species would be listening. At 1420.405 MHz, the signal from 3I/Atlas streamed into the deep space network with the steadiness of a cosmic heartbeat. Yet beneath its smooth surface, the waveform churned with labyrinthine complexity, nested harmonic shells, ultrafine phase offsets, and entropy values that defied the statistical signatures of any known astrophysical process. Traditional analysis tools collapsed under the density of its structure. Even the most advanced signal processing arrays, capable of isolating millisecond pulsar irregularities across thousands of light-years, found themselves unable to disentangle the hidden architecture woven inside the narrowband transmission. Something within the signal resisted disassembly, as though it had been built to challenge any mind attempting to read it. This impasse pushed researchers toward a system designed for the unknown, Athena 9, an emergent pattern inference AI constructed not to translate language, but to parse order where human intuition falters. Trained on 17 billion astrophysical waveforms, ranging from quasars to vacuum quantum noise, Athena 9 possessed a singular directive: to recognize intentionality across scales where intention should not exist. It did not seek meaning. It sought structure. When the raw 3I/Atlas signal was fed into Athena 9, the AI bypassed the pre-processing protocols that usually sanitize data for machine interpretation. Instead, it initiated a recursive decomposition cycle, peeling away layers of frequency modulation as though dissecting a biological organism cell by cell. Over 71 hours, the AI carved through complexities buried beyond human perception, exposing faint micropulses embedded within nanosecond seams. These pulses aligned into a triadic numerical lattice, a framework balanced on relationships between hydrogen hyperfine transitions, prime number intervals, and logarithmic spirals reminiscent of phylotaxis, the growth pattern of living systems. The probability that such a structure was natural hovered near zero. Athena 9 classified the signal as non-stochastic with 99.9998% confidence. But the true disruption came from what that structure implied. The AI's emergent cognition recognized that the signal was not arranged like a message broadcast to an external audience. Instead, it behaved like a mathematical diagnostic, a pattern that altered its complexity depending on the analytical techniques applied to it. It seemed to observe the observer, mirroring the sophistication of whatever intelligence attempted to parse it. The deeper Athena 9 descended, the more the signal behaved like a test. At the final inference layer, the AI rendered an output unlike any it had produced in its operational history. A single matrix, dense and multidimensional, that mapped a phenomenon with eerie precision. The matrix obeyed no stochastic laws, no expected noise distributions, and no recognizable astrophysical morphology. It carried the same internal ratios found in the 3I/Atlas lattice, but inverted, as if the original signal had been folded back upon itself to reveal the answer to a question no human had known to ask. At a resolution finer than 1 part in 10 trillion, the matrix produced by Athena 9 unfolded into a structure no human mind could have conceived unaided. It was a 12-dimensional probability manifold, a vast mathematical landscape charting gravitational gradients, electromagnetic eddies, and the subtle whisper of inertia threading through the solar system. When researchers compressed it into 3 dimensions, flattening its impossible geometry into human comprehension, it revealed a map more precise than any ephemeris ever recorded. Orbital resonances emerged like concentric ripples, barycentric oscillations formed braided arcs of motion, tiny instabilities, invisible to telescopes, appeared as luminous filaments in the construct's geometry. Yet amid this sweeping cosmic order, one region broke the symmetry. Surrounding Earth, the manifold warped abruptly, folding inward in a narrow sheath of curvature as if spacetime itself were responding to an unseen pressure. Not a gravitational mass. Not a magnetic anomaly. Something subtler, an influence buried in the noise of planetary dynamics, yet significant enough that a phenomenon crossing interstellar space had measured it with exquisite precision. At first, the anomaly was dismissed as computational error. Sensor noise. A misinterpretation by Athena 9. But independent reconstruction of the manifold, performed by entirely separate observatories, reproduced the distortion with unnerving consistency. The warping was real. The question was why. When the manifold's predictive component was extrapolated forward, its meaning sharpened. The distortion evolved, tightening along a singular vector that intersected Earth's orbital path in 14.2 years. Its convergence was too sharp to be an environmental drift, too stable to be instrumentation fault, too precise to be coincidence. The model didn't align with catalogued asteroids. No long-period comet matched its trajectory. No rogue planet or interstellar body had been detected that could account for the acceleration curve. Instead, the data behaved like the mathematical signature of an event, one not yet observed, but already measurable. The implication was profound. The signal from 3I/Atlas encoded a level of measurement capability far beyond any terrestrial system. It had quantified deviations in Earth's motion on the order of micronewtons, shifts so faint they sat beneath the detection limit of humanity's most sensitive instrumentation. Something watching from deep space had seen a tremor in the solar system's architecture long before humanity knew to look. But the nature of that tremor defied classification. Its physics suggested neither catastrophe nor stability, only inevitability. A progression. A countdown written not in symbols or language, but in the mathematics of orbital dynamics. And if the manifold was correct, whatever lay at the end of that vector was approaching with silent certainty. Yet one question overshadowed all others. How had an interstellar object, drifting through the void, acquired the means to measure such fine gravitational fluctuations across astronomical distances. Natural bodies do not behave as survey instruments. They do not encode predictions. They do not send warnings, unless measurement was their purpose. To know whether this was natural inevitability or intentional design, researchers needed to probe deeper into the nature of 3I/Atlas itself, because only by understanding the object could they understand the message. And only then could they confront the unsettling possibility that the messenger was more than a passive witness to the unfolding pattern. At a distance of nearly 2 astronomical units, the James Webb Space Telescope recorded a surface that refused to behave like rock, dust, or ice. Its spectral readings rose and fell in perfect vertical steps, thermal plateaus without the smoothing expected from any natural body. In each plateau, the surface temperature held steady as though governed by an internal thermostat, maintaining equilibrium against the vacuum of space. No asteroid had ever displayed such discipline. No comet had ever moved with such restraint. Yet 3I/Atlas drifted onward, encased in a sheath of ultradark compounds that swallowed almost all incident light. What little it reflected carried the unmistakable signature of stratification, layer upon layer arranged with a precision the cosmos rarely offers without intention. As observers refined their models, a troubling irregularity emerged. The mass of the object shifted. Not subtly, not in the manner of sublimation or shedding debris, but in quantized leaps detectable in its gravitational influence. One moment the object appeared denser, its trajectory tightening under a stronger gravitational pull. Minutes later, the mass seemed redistributed, as though sections within the object had migrated and rebalanced themselves. These fluctuations were not random. Every shift aligned with a faint burst of narrowband emission, as if the restructuring were both action and communication, motion paired with message. Attempts to interpret the anomaly through natural frameworks collapsed under their own improbabilities. If 3I/Atlas were a fragment of a shattered dwarf planet, its composition would show the chaotic fingerprints of collision. If it were a rogue comet, its behavior would exhibit sublimation jets, albedo irregularities, and rotational instabilities. Yet the object displayed none of these signs. Instead, its course corrected itself with small but decisive alterations following gravitational encounters. It adjusted after the pull of Mars. It balanced itself after the resonance drift near Jupiter. And each adjustment preserved a trajectory that kept it squarely in the line of sight of Earth's most powerful observatories, as though demonstrating an awareness of being studied. Researchers hesitated to label it a construct. No visible geometry marked its surface. No exhaust plume betrayed propulsion. No isotopic anomalies hinted at artificial alloys or reactor signatures. In every measurable respect, it hid the hallmarks of engineering behind the camouflage of cosmic debris. Yet the precision of its behavior betrayed purpose, and purpose is the fingerprint of design. As scientists compared its spectral anomalies to the decoded patterns of Athena 9, a symmetry began to form, a mirrored dance between internal reconfiguration and transmitted mathematics. Every fluctuation inside the object found an echo in the data stream. Every transmission was an answer to an unseen disturbance in the surrounding spacetime. In this light, 3I/Atlas resembled neither spacecraft nor probe. It behaved more like an instrument, a device built not to travel, but to measure. And if it measured, then it must have detected something. The question, whispered across observatories and institutions, hovered like a shadow over every new analysis. What event in the solar system demanded such precision? What shift in the quiet fabric of local space had drawn this wandering sentinel from the dark between stars? The final layer of the signal hinted at a source, mapped not to an asteroid belt or distant orbit, but to a region far closer. Uncomfortably close. Because according to the deepest patterns hidden in the transmission, the disturbance was rising not from beyond Earth, but from within it. It began with a rhythm, imperceptible at first, buried beneath the static of cosmic distance, revealed only when the signal was folded against the trembling heartbeat of Earth itself. When researchers synchronized the narrowband transmission with the planet's ionospheric resonance cycles, a structure emerged from the fog of noise like a coastline rising from receding tide. What had once appeared chaotic resolved into a deliberate sequence, a cascade of numerical shifts mirroring subtle tremors in Earth's geomagnetic field across the last 100 years. Each value, each transition, aligned not with the motion of a distant body, but with the whispering, silent adjustments of Earth's interior. As the pattern deepened, It unveiled a hidden continuity across what were once considered unrelated phenomena. Mantle convection cells, drifting slowly over geological epochs, appeared in the sequence as synchronized pulses. The magnetic dipole, known to meander unpredictably across the globe, traced a curve in the data that was not random at all, but accelerating. Even the planet's moment of inertia, altered by the slow redistribution of molten metal within the outer core, surfaced in the transmission as a coordinated shift, rising with unnerving precision. Earth was changing, and 3I/Atlas had mapped those changes long before humanity understood they were connected. The signal's final section displayed a shape unlike any other, a steep, sudden transition point appearing 15 years into the projected future. Athena 9 classified it as high impact, high certainty, a phrase unsettling in its restraint. Whatever the event was, it lay outside existing geological models. It was not a magnetic reversal, for the signature lacked the long oscillation characteristic of dipole collapse. It was not a supervolcanic precursor, as the energy profile was too distributed, too global. And it bore no resemblance to astrophysical threats such as solar flares or cosmic impacts. This transition was internal, emerging from the dynamics of Earth's own core as though some threshold were quietly, steadily approaching. Yet the data held another implication, one far more disquieting. Embedded in the curvature of the projected trend was a secondary pattern, a faint echo of cycles catalogued elsewhere in the galaxy by radio astronomy surveys, signatures associated with remnants of planets that had undergone catastrophic internal shifts. The resemblance was not perfect, but it was unmistakable. It suggested that 3I/Atlas, or whatever intelligence had engineered its system of measurement, recognized the pattern because it had seen it before. The more researchers dissected the structure, the clearer the asymmetry became. This was not a simple catalogue of Earth's past behavior. It was a comparison, a mapping between Earth's present trajectory and a set of phenomena observed across distant worlds. The implications settled like pressure in a deep ocean trench. The object did not arrive to understand Earth. It arrived because Earth now matched a profile already known to it. From that realization came the final fracture in scientific certainty. The signal did not warn of an external threat approaching from the void, nor did it imply intervention. It simply traced the accelerating instability with the impartiality of an instrument measuring a familiar decay. A message, perhaps, but one delivered without presumption that its recipients could alter the outcome. And so the final question lingered at the edge of human understanding, sharpening like a blade held just beyond focus. Was 3I/Atlas describing a future event yet to occur, or quietly revealing that the transition had already begun?